Alright guys, welcome back from spring break. We're going to go ahead and get started on the notes. I usually give you about 5 seconds at the beginning of the video, but I kind of forgot, so I'm just going to go ahead and get going. This hopefully will be the last video you will have to watch and listen to me talk. We'll see. I'm going to make the videos anyway, just so they're available for you if you need it, but as far as I know, you should be having a teacher soon. We'll see. So the warm-up here today is looking at some of the theorems from before spring break, and not some of, just one specific theorem that says that the angle here, xyz, is equal to half of the arc that it intersects. So that is going to be this huge arc right here, all the way around the circle. This is the angle we're trying to find. So we need to first figure out what that purple arc is. And all we have to do is take 360 and subtract 110 from it. So our purple arc is 250. And then our theorem says that we just have to take that 250 and divide by 2. So it is 125 degrees. So that's C. So jumping into our notes here, vocab words we're looking at today: chord segment, secant segment, external secant segment, and tangent segment. Lots of segments today. There's one more vocab word that I didn't include in the vocab list, compound locus, because really it's not a word defined in the glossary, so I didn't make you do it. So here's our first theorem. If two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So we're going to multiply the red by the blue and the green by the purple, set them equal to each other, solve for whatever we need to within that. So our first one here, we need to find x. So we have that the 8 and the x are on the same line, so that means we're going to multiply those together. So 8x. And the 9 and the 12 are on the same line, so we're going to multiply those together. So 9 times 12. So 8x is equal to 9 times 12 is 108. And we divide by 8 on both sides. And 108 divided by 8 is 13.5. Fairly simple, I think. So our next problem, same theorem we're using, but now we have a lot of x's all over the place. So we're going to do the same process. So the x and the x plus 10 are on the same line, so they're going to multiply. So x times x plus 10. And then the x plus 4 and x plus 2 are on the same line. So we're going to have to FOIL this out. So x times x plus 10, we just distribute the x, so that's just x squared plus 10x. And when we FOIL x plus 4 and x plus 2, that becomes x squared plus 6x, because there's a 4x and a 2x. Add them together, you get 6x. And 4 times 2 is 8. Now, looks scary, but we have an x squared on both sides. So when we subtract x from one side, it's going to subtract x squared, sorry. From one side, it's going to subtract x squared from both sides. So they're going to cancel. So instead, we're just going to subtract the 6x. So that's 4x is equal to 8 now. We just divide by 4. And x is 2. So it looked like it was be complicated. The most complicated part is having a FOIL. Not too bad. So our next theorem, or not yet, got one more problem with this, sorry. So this problem takes into account a theorem we used to use too, or we used before, that said that if you have a diameter and it intersects a chord, then they are the perpendicular bisector of that chord, right? And that's exactly what's happening here. So what we're going to do here is use the theorem we just learned and that theorem to make sense of this. So we know that the organism is one length on the right side of the diameter, should be the same length on the other side, and that 0.25 we're going to multiply by the length of the other side. The diameter is 2, so 2 minus 0.25 is 1.75. And we know because the organism is one length on the one side, we're going to square that and multiply it by itself, basically. So 0.25 times 1.75 comes out to be 0.4375 equal to x squared. And we square root on both sides to get rid of the square. And x comes out to be 0.661 when you round millimeters. So we rewrite that. And there we go. Okay, now our next example takes into another theorem. So if two secants intersect in the exterior of a circle, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. Whew. Says a lot. But basically the red parts of each line are going to be multiplied by the entire length of each line. So here we have the 8. So the 8 is going to be multiplied by 8 plus x, and the 10 is going to be multiplied by 10 plus 24. So we can distribute the 8, so that's 64 plus 8x, and that's going to be 10 plus 24, so 34 times 10 is 340. Subtract 64 from both sides. 8x is equal to 276. And we divide by 8. And x comes out to be 34.5 and no units. So that's it. Okay. Next theorem says that if a tangent and a secant intersect in the exterior of a circle, then the square of the measures of the tangent is equal to the product of the measures of the secant and its external secant segment. So again, we're going to use the portion outside and multiply with the entire length of the secant equal to the square of the tangent. So the red is our tangent here. So here we have our tangent as 12. So we know we're going to square the tangent, and then we have to multiply our x by x plus 2. So we need to simplify this. 12 squared for 1 is 144. X plus x is 2x plus 2. We're going to distribute that x, and then we end up with 144 equal to 2x squared plus 2x. Now before we do anything else, we had a 2 in front of everything except for the 144, which is even, so we can divide everything by 2. So we divide everything by 2. The 144 becomes 72. 2x squared becomes just x squared, and 2x just becomes x. Much simpler to factor. So now we're going to subtract the 72 from both sides. So we now have 0 equal to x squared plus x minus 72. Now we can factor that. Use whatever method you need to factor. But I know that 9 times 8 is 72, and they are a difference of 1. So if we do a positive 9, because we have a positive x, and a negative 8, because we have a negative 72, that's it. Now, when we simplify that, or we go to solve for x, we have to separate each one equal to 0. So x minus 8 and x plus 9 equal to 0. X plus 9 is going to get us a negative 9. And x minus 8 is going to give us an 8. We can't have a negative here because x is a length, so that's out. X is 8. And you can check that because x being 8, x plus 2 would be 10, so then 10 plus 8 is 18. 18 times 8 should be 144, and it is. So that's our answer. Alright, so equation of a circle. It's fairly I mean, I'm not going to go too in depth with this with you guys. I don't want to hammer it home. In Algebra 2, you should cover this. I don't know if that's still true, but honestly, for me, that's what it was in high school. So here, all you have to do is take the point that's the center, and you're going to use that in the formula. So x minus whatever the x value is for the center, 3 squared, plus y minus the y value for the center. It's a negative 3, so we're going to change the minus sign to a plus and square it. Set that equal, and then the radius is 6. We're going to square that 36. So that's 6 squared. That's it. That's our equation for the circle. Just took what they gave us and plugged it into the formula. Now, they're not always going to be that simple. This one gives you a graph. So our center, and it tells us that one point out there is 3, 3, which is great, but our center is at 1, 3. So using that, our radius is 2, it tells us it. So x minus 1 squared plus y minus 3 squared equal to 2 squared is 4. And that's it. Done. Just need to know what the center point was and plug it in. No signs changing either. Now, this one gives us the center and a point that it passes through, but that point is on the same line in the x or in the y, so that means that we just look at the distance that the x would be. So our x values, our x values being negative 3 and 1, the distance between negative 3 and 1 is 4, right? Negative 3 minus 1 is 4, right? Or we can just do absolute value of negative 3 minus 1. Still 4. So that's our radius. Because we have the center and a point that the circle passes through. So we have the center, that's the negative 3, negative 2. So x minus negative 3 squared plus y minus negative 2 squared equal to, our radius is 4, 4 squared is 16. There we go. So our next one wants us to graph it. We're not going to graph it, but this one is a bit more complicated because what we have to do is actually complete the square 2 times. So we have x squared minus 4x plus some number we need to use to complete the square, plus y squared minus 6y plus, again, some number to complete the square, equal to negative 9 plus each of those numbers. So for the x's, we know that we're going to divide 4 by 2, and we square that. 4 divided by 2 is 2, 2 squared is 4. For the y portion, 6 divided by 2 is 3, 3 squared is 9. So we're going to add the 4 and the 9 here. The negative 9 that we have and the 9 are going to cancel, so we're just left with 4. So now we're going to have x minus 2 squared plus y plus 3 squared equal to 4. And that's it. So our radius would be 2, the center point, which is 2 things that we need as well. So we want the formula, or the equation. We got that. We also want to know the center point, which is at 2, -3. And we want the radius, which is the square root of 4, 2. There's all 3 of the answers. We're not going to graph it, but you get the idea of what that would look like. So, our exit ticket is next, and all I have to say for that is to use Desmos, actually. Oh, there's the graph for that last one. All right, so here's your exit ticket. Use Desmos. Plug these in. It'll graph the circle, and then just look for the points that intersect. You're going to have to round, so it's not going to be exactly 2 or -2, depending on which one you're looking at. All the answers have 2 and -2 in some form. All right, and short video today. Had to get it done in a short period of time. So, hopefully this will be your last video, and if not, make sure you guys come to tutorials. I don't know why you guys aren't showing up for tutorials, but those of you that are in Miss Ween's class, or the class formerly known as Miss Ween's class, you need to come to tutorials. I know a lot of you are struggling. A lot of you are pissed that you don't have a teacher. I understand. I feel bad for you guys. I understand the struggle you're going through. There's nothing I can do about it. You need to talk to Miss Staten. You need to talk to Dr. Brooks. Talk to your AP. Talk to your counselor. Talk to somebody. I can't do anything about it. I can push them, but they're only going to do so much. So if there is a teacher coming, hopefully, I think what I heard, now this is from last week before spring break, that she will be here on Thursday. And I hope that's true. But if not, come talk to me. Come get tutorials. I am here to help you guys, all right? And we'll see you next time if there is one, all right?